Hello, good day viewers. In this tutorial today we are going to learn how to derive the formula of range, horizontal range of a projectile. Horizontal range of a projectile is the horizontal distance from the point where projectile is projected to the point where projectile hit the projection plane. So horizontal range is the distance from this point to this point R. We will use the equation of uniformly accelerated motion to derive this formula. Before we get started, please support my channel by subscribing to my channel and liking this video. Let's begin. For you to get the formula of horizontal range, S will be equivalent to R and U will be equivalent to horizontal component of the initial velocity U cos theta, and A is equals to 0. And the reason why A is 0 is there is no acceleration. That means there is no change in velocity when the projectile is moving horizontally. There is no effect of acceleration due to gravity. So A is equals to 0. So let's substitute this back into this equation, and also T equals to capital T, time of flight, and time of flight is equal to 2u sine theta divided by g. So let's substitute all this back into this equation. S equals to ut plus half at squared. S is equals to r, r equals to u equals to u cos theta, and then t equal to t plus half a equals to 0, and then t equals to capital T squared. Now r equals to u cos theta t, since anything multiplied by 0 is 0. So recall r equals to u cos theta, and this t is time of flight, which is also equal to 2u sine theta over g. So multiply by 2u sine theta divided by g. This equation will also be equivalent to 2u square sine theta cos theta divided by g. Remember, in trigonometry, 2u sine theta cos theta is equivalent to sine 2 theta. So you substitute this back into this equation that says r equals to 2u square sine theta cos theta divided by g. You will substitute this as this into this equation. R is equal to u square, since 2 sine theta cos theta equals to this, sine 2 theta divided by g. So this is the formula of horizontal range of a projectile. Thank you for watching.